So with this video, I'm going to talk about section 2.1. Before I get started, in all my videos, they'll have a little note saying present. Click this present, and this will be a great way for learning because then you can actually see my animation as far as when something pops in and out, and you can actually work the problem before actually seeing the answer. That's probably the best way for learning purposes. So click to present. Always stop the and pause the video anytime you need to work the problem, and then restart the video. And hopefully this will help. 2.1 talks about functions, and with functions, what we're going to do is we're going to actually talk about first, what direction would you begin reading the following sentence? So Mr. Hanson's class, Mr. Hanson's Math 171 class is exciting about learning about pre-calculus. As you notice, we started from the left and we read it left to right. So this is the way, exactly the way we're going to actually read our graphs now when we're talking about increasing, decreasing, and constant. Left to right is what we need to to have our main focus on. And again, just for the directions of increasing, decreasing, and constant. Also, too, I made a note here. Do not use brackets for this concept here. So when the directions ask for increasing or decreasing a constant, you do not use brackets. We're only going to use in parentheses. So make sure in MyFast Plus, you only put parentheses around your answers. So here's a basic parabola. These are called parabola, and this is actually open and downward. So this is what's called a negative parabola. But here, this point of direction change. So here, if we read it from left to right, we notice that going from left to right, it changes directions and comes down on at this point here, which is called the vertex. So if we actually draw a vertical line straight down the vertex here, then we can see that this side of the yellow line is increasing. So it's coming from here. This is a start. I know it's going down, but it's starting from here and going up, reading it from left to right, and stops here. This side over here is called increasing. Now we change the direction. Now it's going downward now. So this side over here would be considered decreasing. Now looking at this one here, the same one occurs from this point to this point here. We see there's a decrease. See how I'm going left to right, left to right. So here we're going down, which is going to be a decreasing part. From this part, left to right, we see that it's going up. That's where we see increasing. So basically for this, only for this first section and this concept, we're only talking about identifying increasing and decreasing. Last example here is called constant. Anytime you have a number in a function, there's no x value of variables associated with it, you'll see a straight line going horizontal, and this is called our constant. So here for part A, B, and C, we're going to figure out increasing, decreasing, and constant. So again, we need to identify. We see this is going down, it stops, changes directions, goes horizontal, stops right here, goes back up, and then comes back down again. So what we're focusing on when we figure out these parts here is the domain or the x values. So we're only focusing on the x ones here. So -1, 3, and 5 are going to be my main focal points. So from here to here, we see that it's going what direction? It's going in the increase direction. So the increase interval is going to be 3 to 5. So 3 to 5 was going to be my answer. Starts at 3 from the left, all the way to the right, 5. These numbers here must be smallest number goes first, larger number goes next. Left to right. Now for decreasing, for this particular one is actually decreasing 2 times. From here to here, and then from here to here. There's 2 decreasing marks here. So from negative infinity, so again, we're focusing on the x. So it's coming from negative infinity all the way down to -1. That's our first answer. And then from 5 to positive infinity, again, not going downward for the y, because yes, it's going down to negative infinity, but we're going to the right. Again, x value is left to right, so it's going to the right. Even though it's going down, it's still going to the right to positive infinity, because these numbers here are getting bigger. So from 5 and to positive infinity is our second part of the answer. So these part here got my little guys going down, decreasing. Now where does the constant? So from constant, we have -1, we have 3. So from -1 to 3 is going to be my constant. So here's a good example for you to try. This is a great way for you to pause the video, give the answers, see if you actually grasp the concept, and then resume with the answer. And here are my answers for increasing. This is my answer for decreasing. So it increases one time here and one out here. That's why we have two answers. And then from here is the only part is decreasing. So -8 to -6, you see the decrease, and have two parts that are constant. From -6 to -3, from -2 to positive infinity are my two constants going from here. Now let's shift directions and talk about max and minimum now. With the max and minimum, we're actually focused on the y coordinates this time. So what we need to do is find out what the x is, and then approximate what the y would be as far as a relative maximum or relative minimum. The best way to do these types of problems is if you put this in your calculator. So you will type in this problem here, and anytime you see dimensions that look like this is considered to be the x min, this is the x max, y min, y max. So if you hit the windows in your calculator, and I can show you this real quick, windows, so the x min will be here, the x max, y min, y max. And the x scales, you can just leave those as 1. So the x scales means how many times the calculator actually goes up. It goes not the calculator, the tick marks on the axis, the XY axis. So you go 1, 2, 3, 4, it goes up by 1s. You can always change this to 5, you go by 5, 5, 10, 15, 20, so forth. But 1 is this is the standard one. If you hit zoom 6, this is the standard default for the calculator. But those where those dimensions come from. So this is where we put it into y equals. Here we see the max. So we're going to hit second, then trace, and then go down to number 4 where it says maximum. Go to the left side, left bound. Go to the right bound, and then go right to and when it says guess, you can just hit enter again, and it goes straight up there in the middle. So this will be the maximum. So this is the only answer we're looking for. Don't put this in the order pair. So for maximum, the only answer I'm looking for is just 2.004, wherever the directions round to in MathFlash+. The next part of this one here is minimum. So we do it again, second trace, and then go to minimum, I think, which is going to be number 3. Go to where the minimum is, go to the left bound, go to the right bound. So you might have to slide your little blinking little cursor to this way and to this way, and then it will tell you what the minimum will be. So if you look down at the answers, it says at the approximate -0.082, we have the maximum value at 2.004, and then the relative minimum when it's at 4.082, we have a relative minimum at -1.604. So if you don't mind, if you want to go ahead and put that in your calculator, give it a try for practice purposes. Remember to hit window and set these so you can see the graph perfectly placed inside of your window screen. Here's another one for you to practice, and these are exactly the same steps I laid out. We hit y equals, put this in your calculator, -3x squared plus 12x minus 5. Zoom 6 is our standard, the way to look at it. This one I'm not giving you dimensions like I did before. So I didn't give you the dimensions because the numbers are not big or small. Usually when the numbers are really big or really tiny, like decimals, is when you have to mess with the dimensions or maybe hit zoom 0 for large or really small numbers. But this one's pretty standard. The numbers are pretty standard. So zoom 6 should work, and you should be able to see a perfect shape of the graph. So we're going to determine where the vertex is. Because it's a negative, it's going to be a parabola that's will have a minimum. And we hit second trace, and because we see the minimum, this is where we're going to be choosing number 3. Go to the left cursor and hit. Now I just say go over 3 places, but you can go over any amount you want to. Then hit enter because that's when it asks for the left bound. Then we're going to go over 3 places to the right, and we're going to hit enter for right bound. Remember, if it says guess, just hit enter. You can just bypass that, and you might sometimes need to round the results. And this is what your answer should be: 2, comma 7. Now it won't exactly probably say 2. They probably have some decimals, but if you round the number in the answer in your calculator, you should get 2 comma 7 for the vertex. So at 2, there is going to be a minimum. I'm sorry, I think I said going this direction, but because it's a negative, it should be going downward, like a frowny face. So this one should be a max. So you should have hit number 4 in that. My correction. So number 4 should be where, look, you always look at the shape. Wherever the vertex is, if it's on top, you hit max. If it's on the bottom, you hit min for 3 and 4. So the max in here will be 7. So at x equals 2, the relative maximum will be 7 for this one. If you, at the last sentence on the bottom, if you ever see e as a result with a bunch of numbers, they'll say e raised to negative 13 or something, then that's when you know the answer should be 0. So just anytime you see e in your calculator as a result, the answer should be 0. So here's another one for you to practice. Go ahead and put this in your calculator. Set your windows for hit the window button and put -3 for minimum, maximum, minimum y, maximum y. This one here, I actually asked for the increasing and decreasing, so you can also find those for extra practice purposes, but the maximum and minimum is what you're looking for as far as the answer. So here's the answer for increasing, here's the answer for decreasing, and then the relative max here at 3, the max will be 4, and then at 1, the minimum will be -8. When working with word problems, it's always best to try your best to draw a picture of what's going on, because the picture is going to tell a lot. Once you get that picture going, then you'll know what is going to help you, what formula, what procedure to do to help you with this problem. So a blimp in altitude 3,500. Altitude means vertical, so I know this is going to be my height. Indianapolis 500 race. The 500 has nothing to do with this problem because that's the title of a race for racing. And the other thing I want to mention too, express the horizontal distance as a function. So this one here, I'm not looking for a specific answer, like the answer is going to be 10 or 100, 1,000. It needs to be expressed as a function. So my answer should look like an equation. So here's my picture. Here's the altitude here, the slanted distance, which is here. And then we have the start and the finish here. So if you're looking at this shape, this looks like a triangle. And what kind of triangle it looks like? A right triangle. With this right triangle, you should be using the Pythagorean theorem. A squared plus b squared equals c squared. So a, b squared, again, a and b don't matter. You can put a over here, b over here, c, it doesn't matter. But a squared equals b squared is equal to c squared. And then we're going to get our then we're looking for h because it says look for the horizontal distance, so we're going to be solving for h for this particular one. So I'm going to go to my whiteboard and kind of lay this out and show you how to solve for h for this particular one. So we see here we have the Pythagorean theorem, a squared plus b squared equals c squared. Again, if you have the right triangle here, the right angle here, whatever is opposite, which is hypotenuse, is always going to be my C. Again, A and B does not matter. So we can label this A, B. You can flip-flop those. Those is not going to matter as far as the problem is going to be. So H squared plus B squared, which is 3,500, is equal to D squared. Once again, we're solving for H. So we need to bring this guy over by doing the opposite. So minus 3,500 squared. We drop down the h squared is equal to d, and excuse my pen if it keeps going in and out, d squared So how do we get rid of a square? In order to get rid of this square here, we have to take the square root of both sides. So that kind of eliminates the square here. So that cancels over here. So that cancels with this square root. So that just leaves with h. And then just in here we have d squared minus 3,500 squared. So that's supposed to be a square. My calculator went out a little bit. I mean my pen, but that's supposed to be square. So this is actually going to be the answer for this particular problem. And when it says expressed as a function. So this is what we're looking for the answer. So now we're going to shift to piecewise function. With piecewise function is we're needing to look at this in three parts. So I would say part A will be, or line A, this would be line B, and this will be line C. So we look at line A, line B, line C. We're given -5. So I'm looking at this part here. I'm saying which one of these am I going to plug this -5 into for X? Notice there's no X here, so there's no plugging in actually needs to be here. Whatever if it falls in between with line B, the answer will always be 5. But for this one and this one, line A and line C, we can plug in something for X. So -5, would I be able to plug it into this first one, or would I plug -5 into the last one for line C? Well, the only way for you to know that is you look over here for these parts here is where it's going to let you know and makes it hold true. So we ask ourselves for -5, let's look at line C. Is -5 greater than 3? Obviously it's not. So we can scratch that out. We're not using line C for -5, so we're not going to plug it in here. But is -5 less than -2? I think it is. And I know it is. So for this one, and it also won't work for this one because -5 is not in between -2 and 3. So we only want to, line A is the only one that will work. So we plug in -5 plus 1, and we're going to get -4 to be our answer for this first part. And the same process go for this one here, -3. Figure out which one of these it will hold true for. -3 will hold true for only the first one. So that's why we're going to plug it in here, get our answer. 0 only holds true for the line B. For this one here, because 0 is not less than -2. So we put it into this one, we get our answer just to be 5. 3 will hold true for this one. So don't make a mistake and put it here because 3 is not greater than 3. However, 3 is less than or equal to 3. So these two will go to line B. So the answer for both of these will be just 5. And then 4 and 10 is obviously going to be greater than 3. So we put it here and square it and get our answer. So we square 4 and get 16, square 10 in here. B's here, because there's nowhere to put an X in, we're just going to say the answer is 5. And then for -3 and -5, here we have -4 and -2 to be our answers. So that's how we do piecewise function. You're given numbers, and we use what's to the right of it to figure out which one do we need to plug the equation in, the number into the equation for to get our answer. So here's another one for you to practice. Once just a reminder, just go ahead and pause the video so you can try to work it out first, and then hit resume the video, and I will review the answers. For this one here, -4, the only way it will work is the top one. It's not great. -4 is not greater than 1, so we only put it into line A, or the first one. We put it in here, -4 plus 4 is 0, so that's why the answer is 0. So you plug in 0 for this one to get 4. Once again, we have to plug it into this one because 0 is less than 1, so we put in here add 4, and so forth. So that's how we do piecewise functions. Now to graph piecewise function, the best way to do is use your calculator to help you assist of what this function looks like and what this function looks like. So if you actually type this in your calculator and put parentheses around the top and parentheses around the bottom, it looks like a straight line going all the way through. However, there is a missing dot here. Why is there a missing dot at -2? This function here is this line, but it cannot equal -2. And why is that? The reason for that is because if we put -2 in the bottom of this denominator here, we have a red flag. -2 plus 2 is 0, and you cannot have a 0 in the bottom of a fraction. That's called undefined. So the answer for this one, you can have any answer that you want, but the answer can never be -2 because the answer for -2 is actually, for -2 is actually going to be 3. So that's why for x equals -2, we have 3 to be our answer. So we draw a line, but we have to erase this little part here and cut it out and put it up here. So it kind of goes from here, stops, jumps up here, and then jumps back down and continues on here. That's what piecewise function is all about. This one here has 3 parts. So we need to figure out what the graph looks like for this one, what the graph looks like for this one, and this one also. And we can draw those lines. I always suggest you do it in pencil. Draw those in pencil because we're not going to take this full line of x plus 1. So if I quickly go to my calculator and put in x plus 1, so x plus 1, and hit graph, see, the calculator gives us the whole length of x plus 1, but I'm not taking all of this. That's why we do it in pencil. The only part I need is the x's that's going to be less than 3, negative 3. X has to be less than or equal to 3. So that's the only parts that I want from it. So I go over to 3, negative 3, 1, 2, 3, come right here, put a closed dot here, and keep this part of your graph. So this other part to the right, you just erase that, get rid of all that. You don't need that part. And it's going to be a closed dot because less than or equal to gets the closed dots that you see here and here. And then less than or greater than with by itself with no equal sign, those gets the open circles. So make a note of that. Less than or equal to, greater than equal to gets closed dots. Less than and greater than just gets open dots. So what is y negative 1 equal? So let's look what that looks like. So I can just drop this down here and put negative 1. You can erase this one. We don't need it, but just to kind of let you see what it kind of looks like with both of them. So basically for this one here, I'm coming all the way up. I'm stopping here and erasing everything else in blue. Then I'm going to resume by starting here at negative 3. I think it's supposed to be negative 3. Where was the graph? Yes, at negative 3. And then continue on to positive 4. So 1, 2, 3. So right around here, we're going to put this graph here, continue on to 4, stop, and then erase all of this side. So I don't need any part over here. I don't need all this over here. So we erase all those parts. All I need is from negative 3 to 4. And that's what we see here, negative 3 to 4. The last one here, you put in 1/2 x in the calculator too. It has the graph, a line looking all the way straight, I think going this way. But the only part we need is anything greater than equal to 4. So it gets a closed dot, keep everything to the right that's greater than 4. So we kept this part because it's x is less than or equal to negative 3. We kept this middle part here because it's constant in between negative 3 and 4. And then from 4 to the positive infinity, anything greater than 4, that's where we keep this part. So this is what a piecewise function graph looks like. So that concludes section 2.1. If you have any questions or concerns, please let me know.